Myers, and today I'll talk about the convergence of design with biology in the 21st century to achieve sustainability. For thousands of years, designers have looked to nature for inspiration and materials, but only in the last few decades has it become possible to consider harnessing life in a literal way for building and manufacturing. I argue that this kind of design using living material is inevitable in a world that's changing, becoming more populated, urbanized, and warmer due to climate change. To distill it into one example, in the 19th and 20th centuries, architects had to turn to engineers, and they were led to incorporate learning from the field of physics to achieve the skyscraper. In the 21st century, designers will need to partner with scientists and really look at the techniques and knowledge built in the field of biology to achieve sustainability. To give you a snapshot of my research and my project, I'll first talk about why this new kind of biomimicry is so important, then walk through the highlights of the history of the material concrete, drawing connections that I think really encapsulate my argument, then look at a specific example of how an architect and biologist work together to solve a specific problem using bacteria, and then I'll give just a brief overview of how I plan to apply my thesis in the form of an exhibition. So climate change, loss of biodiversity, and the increasing scarcity of natural resources are phenomena that don't need an introduction, but I emphasize the urgency to address these issues with design in the coming years. Before the close of this decade, hundreds of millions of people will rise from poverty in places like India and China and enter a new global middle class. In many ways, this is a miraculous development, the result of economic and political liberalization, the spread of new technologies, and global trade. But from the standpoint of the environment, this can be a critically damaging phenomenon if the poor example set by the United States and other wealthy nations over the last 200 years is followed by this new global middle class. As a result, a new biomimetic approach is demanded, which goes beyond metaphor, symbolism, or any kind of stylistic approach. Rather, it's needed in order to pursue achieving the kind of economy of materials and energy that today is found only in nature. As this goal is pursued, the lines between built and natural environments will have to blur. Looking at the highlights from the history of concrete really illustrates, I think, how societal pressures drive technological breakthroughs. Concrete was first widely used by the Romans and was a key component in enabling the empire. The structures that were demanded, some of which still survive today, including barracks, military barracks, aqueducts, ports, bridges, and roads, were all essential typologies to the imperial infrastructure. Not coincidentally, soon after the fall of Rome, the formula for making concrete was lost for 13 centuries, only to be rediscovered at the time and place of the dawn of the Industrial Revolution, mid-18th century England. A century after its rediscovery, concrete changed. The architect François Coinet developed reinforced concrete, which gave it tensile strength and vastly multiplied its functionality. Looking at the kind of structures that Coinet built with this new concrete revealed the kind of societal pressures, economic and political, that were dominant at the time. An aqueduct in Paris, a seawall and docks at Saint-Jean-de-Luz in France, and a lighthouse at Port Said, Egypt, were all closely linked to urbanization and the rise of global capitalism and colonialism. At exactly the same time, in Great Britain, the first reinforced concrete structure was built, a factory in 1897. Fast forward to today, and the ecological burden of concrete is extremely heavy. In fact, for every ton of concrete that's made, approximately a ton of carbon is released into the atmosphere. This is unacceptable. In our era, demands for performance have new dimensions. Strength and durability are no longer the objective. In response, a new kind of concrete has been developed by researchers at the Delft University of Technology in the Netherlands. This innovation is aimed at dramatically increasing the longevity of concrete by making it self-healing. This is accomplished by adding a particular bacteria to the concrete, which lives inside in suspension. These bacteria heal the concrete once it cracks by naturally secreting limestone. When you consider the scale at which we produce concrete, adding just a little bit of longevity to it can actually have an enormous impact. Every ton that you don't have to produce to replace old concrete is one fewer ton of carbon in the atmosphere. So to summarize, we can see the design of concrete through the centuries as a series of responses to economic, political, and now environmental pressures. In a way, the reinforcing agent that's important is moving from iron and steel to bacteria in this example. A recent proposal by Swedish architect Magnus Larsson illustrates the kind of biologist, architect, or designer collaboration that we can expect in the future. In Dune, the problem being addressed is the spread of the desert in Africa. This is a slow-moving, quiet catastrophe that affects the lives of millions of people. It forces whole communities to move, destroys crops, and aggravates political instability. Larsson partnered with a biologist based at UC Davis to propose using the bacteria to solidify the dunes into walls, to stop the spread of the sand, and in theory, provide a starting point or foundation for building settlements and possibly collecting moisture to support reforestation efforts. The important feature of this project is that it responds to extreme conditions of the kind we can expect to see in the next century. It also recognizes the value of harnessing the power of a living organism for architecture. Larsson's proposal offers a solution to a very complex set of social and ecological problems that are exacerbated by climate change. Whether it's exactly the right one is debatable. When examined thoroughly, Dune bears some resemblance to Le Corbusier's Radiant City. Both works call for dramatic, large-scale, and technologically driven approaches to work as a vehicle of some conception of social progress. In Le Corbusier's time, the goal was to stave off revolution by the working classes by improving living conditions through architecture. In Larsson's time, the goal is to alleviate suffering among far-off and arguably little understood populations. Ultimately, Larsson's proposal helps us to see that design, integrated with biology or not, is a product of its time and the people who wield it. Similar to mechanization in the 20th century, this new development will carry with it both benefits and burdens. If our histories of war, waste, and ecological degradation can teach us anything, it should be that we must proceed in this way with great caution. In brief, to apply my research, I plan to organize an exhibition of proposals to restore Jamaica Bay. For this exhibition, teams of architects will be invited to work with biologists and other scientists to develop solutions for reforming the marshlands and other habitats that are quickly disappearing, change the ecology of the bay to begin to undo centuries of pollution, particularly the high levels of nitrogen that are in the water, and to increase the amount of accessible public spaces that are within a natural setting in New York City. In part, I aspire to choreograph the kind of situation that provoked Magnus Larsson to generate his Dune proposal. Practitioners I plan to invite include a variety of scientists, architects, and urban planners that have shown a strong interest in bringing the design and natural worlds into greater harmony with their work. In addition, I will partner with competitions such as iGEM at MIT to take advantage of opportunities to apply new research in synthetic biology. And ultimately, my objective with the exhibition is to create plans that can begin to move us forward towards a truly ecological design approach. Thank you.
Well done.
Thank you.
As you were doing the research for this, biomimicry as a word, as a paradigm is fairly new. Did you have a sense that of what kind of headway it's making in the design practices, architecture, engineering, and so forth?
Yes, I feel like it's being embraced, but it definitely is a term that suffers from overuse. Um, if I see a color green in the rainforest and then decide to paint my Hummer that same green and drive around in it, that's in a way biomimicry, if it's very loosely interpreted.
Well, as you were speaking, I was thinking that if I were in the nuclear power industry, I would say total biomimicry. We're just mimicking the sun. You know, nuclear fission. That's all. That's total biomimicry. So, and I wonder if the romantic metaphorical appeal of biomimicry, as I think I agree with you. I hope it's an amazing. The specifics of how this can actually work are astounding in many cases. But I wonder if there's a risk of that metaphorical appeal sort of blinding the world to solutions to climate change mitigation that aren't necessarily biomimicry.
I think that's fair to say. I think that kind of thing will happen, and I again want to really sound a kind of cautionary note to the embrace of this kind of practice, particularly when it starts to go into the realm of synthetic biology and building organisms, designing them. But I think in the coming years, with the kind of changes that we're seeing, the kind of environmental degradation, the kind of problems that are very severe, any approach that we take is likely to at least be better than what we saw in industrialization and the invention of the tank, the automobile, and nuclear fission.
That concrete example is one I didn't know, and again, I think it's a great, the new self-sealing concrete or cement. Is there, for this to sort of reach its next phase of acceptance in the worlds, in the necessary worlds, does there need to be like a giant, scalable, obvious sort of killer app, biomimicry killer app that will make the world go, oh yeah, I get that?
I think so, and maybe the concrete will be that one, be that example that convinces many people. In speaking with the scientist that led the research on that, he was cautiously optimistic. He felt like the building industry takes a very long time to change, even in a very small way. So adopting something like this might take another decade or two, but it seems to be on its way.
Great. William, thank you very much.
Thanks, Kurt.